It should go without saying that life as we know, it could not continue in its current form without the sun. It does so by supplying the heat and light, which are essential to the continuation of life on Earth. The oxygen that humans breathe is created by plants through photosynthesis, which uses light from the sun. Additionally, it is responsible for the formation of ocean currents, weather, seasons, and the diverse climates we experience. It is estimated that our cherished sun will begin the final phase of its lifespan in around 5 billion years, at which point it will turn into a red giant and eventually consume the Earth. But what if anything occurs earlier and the sun spontaneously blows its top? Stay with us till the end of the video. There's a lot of information to be revealed. Why will the sun blow itself up? When a massive cloud of gas, composed primarily of hydrogen and helium, expands to the point that it can no longer support its own weight, stars similar to our sun are created. In the center of that mass of compressing gas, the pressure is so high that the heat reaches unthinkable levels, with temperatures so high that hydrogen atoms lose their electrons. This causes the heat to reach unimaginable levels. This reaction subsequently releases enough energy to counteract the extreme pressure caused by gravity as it collapses the cloud of gas. The atoms of bare hydrogen combine to form helium atoms, and this process continues until the cloud of gas is completely compressed. Our sun and the billions of other stars in the Milky Way and beyond get their energy from the constant struggle between gravity with the energy released from fusion processes. However, in around 5 billion years, the sun will no longer have any hydrogen to burn. Since the beginning of our solar system approximately 4.5 billion years ago, our sun has been in the phase of its life cycle that is considered the most stable and always has been. The sun will eventually emerge from this stable phase of growth once all of the hydrogen has been consumed. The consequences of the sun's detonation. The diameter of the sun is 109 times that of our planet Earth, and it has enough space inside of it to accommodate over 1.3 million times that number of planets of our size. In comparison to other stars, despite its enormous stature, our star falls somewhere in the center, making it a middle. Wait. There are a few outliers, but generally speaking, stars that are about 10 times more massive than our sun will eventually go supernova and explode. Despite this, our star is much too small to explode into a supernova. But if it were to do so for any reason, it would be approximately 8 minutes and 20 seconds before we were aware of the event. This is due to the fact that the distance between the sun and Earth is quite great, averaging somewhere about 150 million kilometers. After 8 minutes and 20 seconds of traveling across this distance, the light from the sun reaches us. We wouldn't be able to hear the explosion if the sun were to go supernova for any reason. Therefore, we wouldn't find out about it until it was too late. This is another reason why we wouldn't know about it until it was too late. This is due to the fact that sound that was conveyed across space would be of an extremely low volume. Because of the magnitude of the explosion, other planets would all be obliterated in their wake. On the other hand, the light debris and shock waves from the explosion would not reach us until after all living beings on Earth had perished. The role of silent killer. Radiation in the form of neutrinos would be the first thing to eradicate all life on Earth in the event that the sun was to experience a catastrophic explosion. Neutrinos may be hitting our bodies at a rate of billions every second, yet they have no effect on us because they do not interact with matter. However, during the explosion of a supernova, the number of neutrinos increases by a factor of 10 quadrillions, and their energy also increases, which results in a significant rise in the likelihood of interaction. Neutrinos travel at almost the speed of light and carry approximately 99% of the energy produced by a supernova. This indicates that the interaction will cause the majority of organisms to explode from the inside out in a matter of seconds. The fact that neutrinos may pass through any material is perhaps the most terrifying property of these subatomic particles. Whether you were to be struck by a neutrino, it wouldn't matter whether you were on the opposite side of the planet facing away from the sun. When a supernova was spotted in 1987 at a distance of approximately 168,000 light-years, astronomers were able to detect the neutrinos from the explosion within a couple of seconds, although the light from its explosion wasn't visible for several hours. This indicates that if the sun were to burst exactly at this moment, the neutrinos would completely destroy everything on our planet before the light from the explosion would reach us. The explosion's effects on the environment, including shock waves. Imagine for a moment that the supernova that would destroy our planet won't be as strong as predicted. In that scenario, the shock waves generated by the explosion will almost certainly destroy anything on the side of our planet that is facing the sun. If this happened, the temperature on the opposite side of the planet would skyrocket, and it's also conceivable that it would be completely enveloped in darkness because the sun will no longer be in the sky. Nothing will have the ability to protect our planet from being pulled out of the solar system by its own gravitational pull. Because of this, our planet will eventually break free of the solar system and find itself floating aimlessly in space. Temperatures on Earth would continue to fall until they reached -18 degrees Celsius a week after the explosion and remain at that level. Temperatures on Earth might reach -73 degrees Celsius within the next year and a half, at which point even the oceans will begin to freeze over. Our atmosphere will start to degrade, and everything will become more vulnerable to the effects of cosmic radiation as our planet continues to drift further away from the sun. Even in the most optimistic scenarios, it's possible that the only life forms that would survive are bacteria and multicellular life forms that are concealed in the hydrothermal vents. At some point in the future, it is possible that our planet will become entangled in the gravitational field of another star. If the star is analogous to our Sun and the Earth, eventually settles into the same orbit inside this new planetary system over a period of millions of years, then there is a possibility that life may once again exist. Will there be a future for humanity? If for some reason the sun were to spontaneously blow up today or tomorrow, the human race would perish. On the other hand, if the explosion isn't strong enough to end our existence, and we have advanced warning that it will take place, we might have the opportunity to live for a few more years after it takes place. For instance, the temperature of the Earth's interior is higher deep beneath than it is on the surface. The temperatures are approximately 23 degrees Celsius, approximately 10 feet underground. It is possible for humanity to survive without the sun for a couple of years in subterranean reinforced bunkers if sufficient resources and the appropriate technologies are made available. It is likely that underground cultivation of edible plants will become feasible with the development of these technologies and techniques. If there is sufficient room and humanity prepares in time to master the necessary technology and skills, it is also possible to keep cattle underground and produce energy through nuclear or geothermal means. Both of these scenarios are possible. However, the unfortunate truth is that under these circumstances, only tiny groups of people living in colonies would have been able to survive, and even then, only if they were well prepared and had received adequate training and preparation. Existence after the sun. The heat that exists on our planet is caused by the light that comes from the sun. If it doesn't exist, the planets in the solar system as a whole will have a far lower average temperature. Because of this, it will be more difficult for life to persist within the solar system. A white dwarf does not emit a significant amount of light. However, in the far future, mankind may construct spaceships that will make it possible for us to abandon Earth. There is a possibility that humans could construct something that could move the planet. If this were to occur, then the planet would be able to survive the sun's transition into its red giant phase. Over the course of several billion years, the sun will evolve into a red giant and, finally, a white dwarf. This has been going on for quite some time. Although we can't see a star's birth and death, we may discover much about them by observing the stars in our Milky Way galaxy. There are young stars, elderly stars, and even deceased stars in the Milky Way, and scientists have figured out their chronological age over the years. The fate of our sun in the distant future can be deduced from observations of these old, faded stars. Thank you for watching. If you have any questions, let us know in the comments section.